Hello, welcome to EGR 185 tutorial. In this tutorial, I'm going to go over how functions can be fun. I'm starting out with a program that simulates a stoplight. We have 3 LEDs, red, green, and yellow, and they turn on in sequence. So you can see my code here, very basic. I defined some pin numbers, 2, 3, and 4. Then I set up the pins using the function pin mode, and these are called macros if you haven't encountered that before, but basically they just replace whatever word is in there with the number defined here. Next, in my loop, I write each pin high, pause for a little bit, then write the pins low. Pretty basic stuff, you've probably seen it before. Functions are a way to break your code into reusable pieces. This is called modularity. Good functions have 3 characteristics. They're short, usually 5 to 15 lines is a good rule of thumb. They only ever do one thing. And they're reusable. So where do functions go? There are 2 different places you can put functions. The first is before your setup. So you can define them right in this area. After your macros or any library calls, and before you call your main code. The second place that you can put functions is underneath your code, and I'll go into that later. So let's make some functions. First, we have to define our functions. We're going to define 3 functions, one to turn the green pin on and off, one to turn the yellow pin on and off, and one to turn the red pin on and off. So let's type that. A function has 3 different parts. It has its return type, its name. We'll name this one green on off. And then it has its arguments. Those will go in between these 2 parentheses. I'll explain that later. Next, you write curly braces, and then you define your function. Well, I've already written some code that turns the green pin on and off. So we'll go ahead and take that out of there and put it in here. And there, I now have a function that I can use to turn the green pin on and off. I'm going to do that again for the yellow pin. And we'll copy and paste. And finally, the red pin. So now we have to use these functions. We use functions by calling them by their names. A function call looks like this. We give the name. So we start with green. And then we would give the arguments in here. Like I said, I'll go over the arguments later. So now let's do yellow on off. And then red on off. Always remember your semicolons. Let's give that a save. Upload, see if we missed anything. Doesn't look like it. Great. And now you can see that we're cycling green, yellow, and red. Great. So let's see if these functions that I just wrote meet the requirements of a good function. First of all, you can see they're short. They're each only 3 lines, 3 usable lines. Or executable lines, I should say. They only do one thing. So this just toggles the green pin on and off. This just toggles the yellow pin on and off. And finally, this is reusable. If I had a sidewalk crossing function, I could potentially reuse this to turn a green LED on and off for the sidewalk crossing. So function calls don't just need to be in our main loop. They can actually be called by other functions. So a function can call a function, and so on and so forth. So we're going to make another function, and we'll call this, it'll be a return type of void, and we'll call it stoplight cycle. And in our stoplight, we'll go ahead and call the 3 functions that we used to call in main. I'll just take these out of here because why type when I don't have to? And then in our main loop, I will just call stoplight cycle. Go ahead and upload that again. And we can see it works just the same as if I had called the individual functions in the main loop. Now our functions are kind of long, and it takes us a while to scroll all the way down to see what's actually happening in our main function. So what we're going to do is we're going to talk about the second type, or the second place that functions can go. And this involves prototyping. So a prototype of a function is just the function's name. So for example, we have the stoplight cycle right here. We'll prototype that by typing its return type, its name. Its arguments would go in here, which I will still talk about soon. And then a semicolon. And we have to do that for each of our functions. And then we can move all of our functions from the top of our code to the bottom. Let's save and compile that real quick. So this way you can order the functions in any order you want. You can do them from least favorite to least favorite, or alphabetically. Sometimes functions need information. For example, stoplights need to know how much time to wait between changing from green to yellow and yellow to red. We can give our functions information by passing arguments to them. I'm going to change our 3 color functions so that they accept an argument that tells them how much time to stay on for. I do this by changing the definition of the function and putting an argument in it. An argument has 2 parts. Its type and its name. So we're going to pass green an int, and yellow is going to get an int, and red is going to get an integer. Now, in these prototypes, all you need to do is tell it what type to expect. So you don't need to put a name in here, but you can if you want to. When we're defining the functions here, you do need to put the name. So in our prototype, remember, green on off took an int. So I can type that in here, but I also need to type a name for it. We'll call this green delay. Underscore delay. Now we can use that argument within our function. So we'll put green delay here. So when we call our function, the argument value is going to be in these parentheses. So let's go ahead and do that now. We'll go to our stoplight cycle, and in green on off, we're going to pass it 500 milliseconds. So that means that 500 is going to be passed as green delay and going to end up here in the delay function. Let's do that to the rest of our functions. We'll do yellow delay and red delay. And we'll place this 1000. And this 1000. Finally, we're going to pass 500 into each of these. And let's go ahead and upload. As you can see, it is going a little bit faster because the delay is now at 500 milliseconds instead of 1000 milliseconds. So we're going to adjust our stoplight cycle function so that now it has a return type. It used to be void. Now we're going to give it a return type of int. So what does that mean? That means that this function now gets to talk back to the function that called it. So here in our main loop cycle, we're going to declare an int. We're going to call it final delay. And we're going to collect whatever stoplight cycle returns. So first we got to return something from stoplight cycle. So we'll return, again, notice this is a keyword, 2000. So now we want to collect that 2000 after it returns. So we're going to say final underscore delay equals stoplight cycle. So what this should do is when stoplight cycle is called, it will do its green on off, yellow on off, red on off, and then it's going to return a value of 2000. Well, now we want to do something with whatever the value returned. So let's delay for the final delay time. And you know what? Let's also reuse our red on off function. So maybe take a minute and try to figure out what this is going to look like when I compile it and load it onto the board. Oops. Put in some stoplight cycle. All right, I had to make a couple of adjustments. Should compile now. You can see from this that we go through a cycle, then it goes to the red on off again, which is why the red stays on a little bit longer than you'd expect. And then we have a pause of 2 seconds. That pause of 2 seconds comes from the stoplight cycle returning a number 2000. Thank you so much for watching this tutorial, and remember to reach out to your TAs if you have any questions or are struggling with anything. We're always here to help.